Now, there are a few different parts on a motorcycle that are often replaced with aftermarket parts. It's usually considered an upgrade, but sometimes it's just for personalization. In the case of rear sets, the adjustability they offer can really contribute to comfort, so this is probably one of the top modifications to make. Now, there are very few manufacturers that actually produce some beautiful rear sets, not just anodized coloured rear sets. And since I've never modelled them before, this is going to be a practice run at modelling some CNC machined rear sets. Now, I won't be using any images for reference, I will just be figuring out as I go. So usually if I'm going to design something like this, I'd want to examine the parts, preferably in person, and then really think about how I want to design this for myself. So we'll take measurements for the mountings, where your feet are going to be on the pegs and where your toes are going to be. And when I don't have good reference material, just to keep it simple, I'll try to keep the mounting as close to the original as possible. And since this is a weight-bearing part, it's also a good idea to take some references for material thickness from the stock parts and other aftermarket parts. With the stock parts being castings, they're not really going to be a suitable reference when we're looking at CNC machined parts. So you'll see in the model tree, I've already tried to set up the components that are going to be in this assembly. Now the first part I'm going to model is the mount plate. And this because it's going to bolt to the frame, and then the other parts are going to bolt to this. Now I'm not going to show the whole process here, but I start with drawing out my mounts and then some sketches to show where the struts are going to go as they go back to the Clevis piece. I sketch out the plate, which is going to have a series of holes which provides the adjustability for the rear sets. But I also try to make the design a little bit more interesting than just being a square block. Now, best practice would usually be to add these holes last as the final machine process, but in this case I'm just really roughing this model out. It's really more of a concept just to get the feel for modeling this part. But it's still important to make sure that all the holes are constrained with the right dimensions for the next part that we're going to be building. So we extrude the profile to get the plate. And then we start adding the mount holes, and then after that we'll add some additional details just to spice up the design. So I quite like these two distance chamfers. You can sometimes make them even more interesting if you turn off the tangent chain and you only select specific edges. But for this case, I was okay for it to run round from mount to mount. So the next plate is mounted to the mount plate using the joint feature, relating it to the bolt holes. We sketch out the profile, connecting the dots between our mounting locations and where our clevis is going to be. Then we make it solid, and then we add in some extra features like chamfers to make these edges a little bit more interesting. It was actually around this point that I wish I was actually using surface modeling. It's much more free to make more complex geometry, to make more interesting surfaces. This is probably more of an experience thing because I've got over 10,000 hours of experience in surface modeling in industry, and in industry 0 hours almost in solid modeling. So I revised the design of this intermediate plate to have this boss at the back. And my plan is to put a bolt in from the backside, and that's going to be a wasted bolt. So it's going to thread into this plate, then it's going to have a non-threaded section. And then the end of the bolt, there'll be another threaded section. So that end thread is going to be where the peg clevis is going to thread onto. And that non-threaded section is going to be inside a spacer. So the purpose of this spacer is to provide a surface for the clevis to pull up against and to tighten against. Because in a moment I'm going to be adding the brake lever. and that needs to sit between the clevis and the intermediate plate without being pulled up tight into that joint. So with the clevis, I just want to make it less blocky here. So here I add a boss, and this is going to be the pivot point for the brake lever. From there I sketch out the profile for where I want the toe to be. So this is not the best method to do this, but it got the job done for me. So I extrude this profile and I overextend it. Then from the front plane I extrude another profile, which I then intersect with that body. So for the Toepin I've got two mounting points, and I want this to be a screwed in part. So the initial part is slightly smaller in diameter, and that part's going to be threaded. Then we have the pin, and then I revolve a half circle around to create this sphere at the end. That sphere is to retain the rubber piece. Then I want to add some detail to this rubber piece. So I start just sketch out a square, and I revolve that around the piece, only around just less than a third of the full revolution. Then from there I use the linear pattern along the axis to repeat this feature along the length of this rubber piece. And then I use the circular pattern to repeat this cut around the rubber piece. The original feature is selected individually, but the rest are part of a separate feature, so they all get selected in one go. And I want 3 instances of these features around the rubber piece. So now looking in the clevis, we need a block which is going to be the pivot for the peg. Now for this to be square like this, it's not going to be able to rotate within this clevis, so we need to round off the edge that's going to be rotating towards, and then we need a hard stop on the other side. So basically when you put your weight against it, it's going to be up against the clevis and it's not going to be moving. Now when you're actually designing this part in industry, we have to be careful because we need to design in a clearance, but also with that clearance it means that when you actually bump up that stop against the clevis, we're going to have some droop in those pegs. And to make things worse, we're modeling in a nominal condition, which doesn't take into consideration the tolerances. So what we would do is model this in a worst case scenario, just as a check, because those tolerances are going to greatly impact the degree that the peg is drooping. So for this peg, I thought I'd just make a knurled round peg. No complicated machining or casting features on the underside. It's also going to be missing that pin on the underside, which is usually the first thing to contact the ground. I believe it's known as a feeler pin. Here I just want to extend it a little bit because it's a bit too stubby. So I want to add the same machine feature that I added to the toe rubber. Just a small machine cut at the beginning and the end of the peg, and one in the middle. Also, like before, we'll use the linear pattern to create the repeated features. Now for the knurling, if this is a real part that I plan to manufacture, I would be designing and modeling the knurling myself, so that I could then define that detail in the drawing. But in this case, since it's just a rough concept, we can go into rendering and go to the materials tab. In the library we'll find a knurled effect. So I come back to the intermediate plate to add the mount features for the heel guard. This is something that I missed originally. I added a joint origin and I realigned that between the two holes so I can get the heel guard in at a nice angle. Then I start with a very rough sketch just to define the profile, and I add in some rounds to smoothen it out. After this, I tidy up the mounting area so that we can have some actual mount features with bolts. This is very rough. Then I added some simple cuts just to make it a little bit more interesting. And then come into rendering to define the colors. Now I'm not really a big fan of these very colorful anodized parts. I do really like the gunmetal, and then when you add a little bit of that color, that's when I think you get a nice design. So I'm a bit on the fence of whether I like this kind of heel guard, so I thought I'd come in and try to make another design. So here you can see I've thickened it up so that I can add in a 2-distance chamfer. And when we add this, it's going to affect the mounting locations, so I'm going to need to rework those in a moment. Here I just decided to cut it back. I should probably have just made this cut a straight cut. It would have been a bit smoother going forward. Then I used the draft feature to pull this edge back, and then add some rounds to smoothen it out. I'm thinking here that I want to add some detail to the main surface of this part. So I'm going to sketch a profile on here, cut that down, and then add in some draft and some rounds. That draft can be added in the taper of the extrusion. So this is my final practice model using solid modeling. Now I didn't have any reference images, and also I was trying to keep in mind that the manufacturing process of this part would be CNC machining. Now of course I want to try this again, but I'll be doing it with surface modeling, and I'll be really trying to make more of a finished product level design. I will try to get it CNC machined, and if I can't do that, then I will just 3D print it myself and then work on making the finish look as realistic as possible. And if these kind of projects interest you, then please consider subscribing and following along. Thank you for your time.